Hello students, welcome to aimstoday online classes. This is a chemistry session. Here we are discussing about the structure of the atom. In this session we are going to say about the particles which present inside the atom, which are called as subatomic particles. We have learnt in the earlier chapters that all matter is made up of atoms. Atoms are the building blocks of every matter we have studied. The first modern atomic theory was proposed by John Dalton. According to his theory, according to Dalton, atoms were indivisible. That means that they could not be divided further into smaller parts. He assumed that atoms are the smallest particles of every matter. They cannot be divided further into smaller parts. Atoms of an element are all identical to each other and different from atoms of the other elements. These are also the points from John Dalton's atomic theory, isn't it? He told that atoms are the smallest particles of every matter and they cannot be divided further into smaller parts. And even atoms of an element are same in all respects, and atoms of different elements are different from each other in all the properties. And even atoms are too small to be seen with the naked eye. Scientists relied on the indirect evidence to prove the existence of atoms because they cannot see these atoms with the naked eye. Why? Because these atoms are very, very small, very, very tiny, which cannot be seen with the naked eye. Since they could not see the atoms, scientists they could find its properties on the basis of certain experiments. Very soon, they realized that atoms could gain or lose certain charges. During electrolysis experiments, Michael Faraday discovered that atoms were acquiring negative charge during the process of electrolysis. So, Michael Faraday found that atoms are acquiring certain charges, so even acquiring negative charges during the process of electrolysis. Michael Faraday's discovery raised a few questions about the indivisibility of atoms, as these atoms he observed as they're acquiring certain charges. Then certain doubts were arised then. What are those? How the indivisibility of atoms is existing, even they are getting certain charges. It is a contradiction to Dalton's theory because Dalton told that atom is an indivisible particle, but atoms are attaining certain charges. This led to an idea that there must exist some tiny particles in the atom which are responsible for the atom to behave sometimes as charged particle. So these acquiring charges by the atoms led the scientists to assume some points. They thought that atoms are not being smaller particles. There must be certain smaller particles than the atom inside the atom which are responsible for the charge acquiring of atoms. As atom is considered electrically neutral, it is probably had some positive constraints and equal number of negative constraints to maintain its electrical neutrality. This gave scope to think about subatomic particles. Okay, atoms are generally being neutral, electrically neutral, but certain times they are acquiring certain negative charge. So these points, these experimental evidences led the scientists to think about the subatomic particles. They assumed that atoms must contain certain particles with the positive charges and the same number of particles with the negative charges to maintain the electrical neutrality. So in this way, they have started discovery about these subatomic particles. Now let us see about these subatomic particles. In science, theories change when scientists discover new facts or clues. Sometimes, an idea or model must be changed as new information is gathered. Yes, they are being changed from time to time. For example, if you take the same Dalton's atomic theory, Dalton told that atom is the smallest particle which is indivisible. But here, scientists they have discovered these subatomic particles inside the atom. So Dalton's theory has completely changed. It is remodified. Dalton proposed that atoms could not be divided, but they found the subatomic particles inside. So experimental evidence began to show that atoms were divisible and are made up of small particles. Since these particles are smaller than the atom and are present inside the atom, they are called subatomic particles. So by the discovery of these subatomic particles, Dalton's theory is almost discarded. In this way, not only the Dalton's atomic theory, almost time to time, some theories has been modified, changed, and some are completely discarded. It is happening because of the discovery of new facts and clues. Okay. Since atoms are neutral, they should have at least two types of subatomic particles. One is positively charged and the other is negatively charged. So that, and these two will be generally equal in quantity. So that negative charge will be counterbalanced by positive charge and hence atoms will be remain electrically neutral. In fact, three different subatomic particles have been discovered. The third one is a particle without any charge. Let us see how ideas about atoms have changed over the time with the discovery of subatomic particles. So what are the subatomic particles here? The particles that make up the atom or the particles that are smaller than the atom are called subatomic particles. The three main subatomic particles that form the atom are electrons, protons, and neutrons. And nowadays we know inside the atom there are around 100 types of particles existing inside. So these all together called as subatomic particles. Out of these all, the main particles which are forming the atoms majorly are called fundamental particles also. Among these subatomic particles, as we told, around 100 types of particles exist inside the atom. Out of these, the three main particles are electrons, protons, and neutrons. That is why these three are specially called as fundamental particles also. Okay. Now let us say about these one by one. First, let us say about the discovery of electrons, which were earlier called as cathode rays. So electrons are one of the three main types of particles that make up atoms. The existence of electrons in an atom was shown for the first time by J.J. Thomson in 1897 by passing electricity at a high voltage through a gas at very low pressure in a discharge tube. Here, discharge tube is a long glass tube which is connected to a vacuum pump for controlling the pressure of the gas inside the discharge tube. So discharge tube is a long hard glass tube which is closed at the both the ends, and the pressure of the gas inside the discharge tube is maintained at very low pressure by using a vacuum pump. When gas pressure inside the discharge tube is 1 atmosphere, no electric current flows through the tube. We know gases are poor conductors of electricity at normal temperature and pressure, isn't it? So in the atmosphere so much gas is there. So it is not conducting any electricity. That is why we are not getting an electric shocks when we switch the electric switches on. Because these gases are poor conductors of electricity at normal pressure. That is at 1 atmosphere pressure. If the gas pressure is reduced to 10 to the power of minus 2 atmospheres, means to very very low pressure, and a potential difference about 10,000 volts is applied to the electrodes, an electric current flows on the same time light is emitted by the gas. So this is a experimental setup of discharge tube. This is called, this blue colored glass tube, hard glass tube is called discharge tube, which is closed at the both the ends. Into this, A. Thomson inserted two electrodes at the both the ends, and he arranged a vacuum pump to maintain the pressure of the gas taken inside at very low pressure. How much it is? 10 to the power of minus 2 atmospheres pressure is maintained. Very very low pressure. What is the normal atmospheric pressure? is 1 atmosphere. It is normal atmosphere per year. But at this pressure, gases cannot conduct electricity. That is why he created inside the discharge tube pressure very low. That is 10 to the power of minus 2 atmospheres. And through the electrodes, he applied high voltage current. Around 10,000 volts of electricity is applied. Then he observed certain flashes appear at the back of the anode by keeping a screen at the back of this. He observed some particles are moving from this side to this side in this way and they're falling on the screen kept backside the anode. So as he assumed these particles are emitting from the side of cathode, he called those particles as cathode rays. Okay, the color of the light depends upon the nature of the gas in the discharge tube. If the gas pressure is reduced to 10 to the power of minus 4 atmospheres, means if it is reduces still to very low pressure, the emission of light ceases. Instead, the tube glows with the faint greenish light. This fluorescence was caused due to the bombardment of the walls of the tube by rays emitted from the cathode. These rays he called as cathode rays, which are negatively charged because here these particles are emitting from cathode side to anode side. So he arranged a screen at the back of anode and he observed the flashes scattering on the screen as particles are scattering that screen. He called those particles as cathode rays, which are having negative charge. The term electron was later coined for these cathode ray particles by the scientist G.J. Stoney. Okay, first they were called cathode rays. Means why they are called cathode rays means they absorbed in the discharge tube. These particles are moving from cathode side to anode side. They appear like generated at the cathode and striking at the anode end. That is why they call these particles as cathode rays. But later on, G.J. Stoney coined this name electron for these particles. Properties of cathode rays. Cathode rays are nothing but electrons. Electrons were the first subatomic particles discovered and studied. An electron is represented as E minus, generally in the expressions. The electric charge on an electron is 1 unit negative, which is also equal to minus 1.6 into 10 to the power of minus 19 coulombs. This is the charge of each electron, which is generally considered as 1 unit negative charge. The mass of an electron has been measured and found to be 9.11 into 10 to the power of minus 31 kilograms or 9.11 10 to the power of minus 28 grams. The mass of an electron is about 1840 times 1 by 1840 times that of hydrogen atom. That is 1 by 1840th part of hydrogen atom's mass. And so it is treated as negligible. The mass of electron is very small and when compared to the mass of hydrogen it is being 1 by 1840th part of the mass of the hydrogen. So it is very small and it is generally negligible. It is treated as negligible mass. But quantitatively it is equal to 10 to the power of minus 11 into 10 to the power of minus 28 grams. An atom is electrically neutral, but the electrons present in it are negatively charged particles. So if only negative charged particles are present, the atom would not be neutral. So here, after the discovery of electrons, this doubt was arised. That is, at the starting itself it was proved atoms are being electrically neutral. But later, they discovered the particles inside the atom which are having negative charge, that is cathode rays. They discovered these cathode rays present inside the atom which are having negative charge. So if there are only these negatively charged particles, cathode rays inside the atom, atoms should not be with the neutral charge. They should be the negative charge. But atoms are being electrically neutral. Then Why the atoms are being neutral even though they contain negative charged particles? This doubt led to certain assumptions there. The atom must also contain some positively charged particles so that the overall charge on it becomes neutral. This subatomic particle would have a charge that balances the charge of the electrons. This subatomic particle was named as proton. So this doubt led to the discovery of another subatomic particle that we call earlier as anode rays, which we are calling as now protons. Now let us see about the production of these anode rays or protons. Protons were discovered in anode ray experiment. So Goldstein is credited with the discovery of protons, the positively charged particles. He used perforated cathode in the discharge tube. So the experiment which was done by J. Thomson, the similar experiment was done by Goldstein again. But here he used a certain perforated cathode instead of direct cathode plate, and he kept a screen backside of this cathode. Now, on passing the electric charge at low pressure, he observed a new type of rays streaming behind the cathode, striking this screen at the back of cathode and glowing. Scintillations he observed. So he considered some particles are moving from anode side to cathode side. So he called those particles as anode rays. These rays are named as anode rays or canal rays. So what are the properties of these anode rays or protons? A proton is represented as P plus or P. Protons have a positive electrical charge of 1 unit positive charge, which is equal to 1.602 into 10 to the power of minus 19 coulombs. That is the charge of a proton. If you observe, the charge of electron and charge of proton both are numerically equal, but the charge of electron is negative quantity, whereas the charge of proton is positive unit. That is why in an atom we say there will be equal number of protons and electrons, and hence atoms are being electrically neutral because the positive charge of protons is being counterbalanced by the negative charge of electrons, which are in equal quantity. Okay, the mass of proton is one atomic mass unit, which we simply say as AMU. 1 AMU. Proton mass is 1 AMU. But actually to say it is not exactly equal to 1 AMU, it is equal to 1.0072 AMU. This is the mass of one proton, which is about 1.67 into 10 to the power of minus 27 grams. Not kilograms, it is yes, kilograms. Or together with the neutrons, they make up the virtually all the mass of the atom. So the total mass of the atom is because of the protons and neutrons present in the nucleus of the atom. Because we told electrons mass is very small compared to that of mass of protons. So we consider that as negligible mass. Now the total mass of the atom is because of the protons and neutrons only. Okay. An atom mass unit is equal to 1.67 into 10 to the power of minus 27 kilograms. Yes, we told here mass of a proton is equal to 1 AMU. 1 AMU nothing but atomic mass unit. 1 atomic mass unit is equal to, in terms of kilograms, if we say that 1.67 into 10 to the power of minus 27 kilograms. So we can say the mass of proton is equal to 1 AMU. Okay. Now let us see the discovery of third fundamental particle, that is neutron. In 1932, James Chadwick discovered another subatomic particle which had no charge and had a mass nearly equal to that of a proton. It was eventually named as neutron. James Chadwick bombarded the element beryllium with alpha particle. So here actually it is alpha particle with alpha particle. Alpha particles are emitted by the radioactive elements and are helium ions with a double positive charge. Alpha particle means the particles with 2 units positive charge, which can be represented like this, He2 plus. This is called alpha particle. Nothing but we know helium has 2 electrons, 2 protons and 2 neutrons. Now, if 2 electrons are removed, then it will be He2 plus ion. Now, what it is containing? 2 protons and 2 neutrons. So, the bunch of these 4, 2 protons and 2 neutrons together called as one alpha particle. Alpha particle means the bunch of 2 protons and 2 neutrons. So, these particles are emitted generally from the radioactive elements. We'll learn about these radioactive elements in the further classes. Example for the radioactive elements are radium, uranium, thorium. They will be emitting continuously certain radiation. That is why they are called radioactive elements. And these elements will produce these alpha particles. Remember, we cannot create these alpha particles from helium atom. Just for the reference, we say it is a nucleus of helium. That means it is not created by the removal of 2 electrons from helium, because removal of 2 electrons from helium is highly impossible, because it is a very small atom that cannot lose its 2 electrons. So but these alpha particles can be produced from radioactive substances. When they are decomposing, 2 protons and 2 neutrons together, they will come out in the form of alpha particle. In that way they are generated. Now, here James Chadwick, he used these alpha particles emitted from radioactive elements. He made these to fall on beryllium atoms, to hit the beryllium atoms. Then what happened? He observed that beryllium changes into carbon. So this protons, two protons, two neutrons bunch, which we call as alpha particle. It hit the beryllium atom, and that beryllium atom changes into carbon, and thus neutrons are emitted in the reaction. See here we can see the reaction what observed there. He used certain beryllium atoms. Onto this, he passed these alpha particles. When they hit this beryllium atom nucleus, that converted into carbon atom, and some other neutral particles are emitted, which he called as neutrons. So these neutrons are having 1 unit mass, and there is no charge for these particles. Okay. In general, a neutron is represented as N0, where 0 represents its charge. It has no charge. Let us see the properties of these neutrons now. Unlike protons and electrons, which are electrically charged, neutrons have no charge. That is, they are electrically neutral. Neutrons are having no charge. The mass of a neutron is slightly greater than the mass of proton, which is nearly equal to 1 atomic mass unit. That is AMU. So mass of a neutron is taken as 1.674 into 10 to the power of minus 27 kilograms. Or if you say in terms of AMU, it is considered as 1.0086 AMU. Whereas for proton it was taken as 1.007 AMU. That means the mass of neutron accurately to say is slightly greater than that of proton. But in general in calculations, the mass of proton and mass of neutron are considered as 1 AMU, that is 1 atomic mass unit, nearly equal. But to say accurately, mass of neutron is slightly heavier than that of proton. Okay. A neutron also has about the same diameter as a proton, that is 1.7 10 to the power of minus 17 meters. It is not 17, it is minus 17 meters. Okay, should be minus here. So proton and neutron almost they have same size. This is about 3 fundamental particles: electrons, protons and neutrons. Remember one thing, atoms they contain nearly 100 types of subatomic particles in them. Not only these 3 particles, There will be some other particles also, which we call as mesons, positrons. These are like this, around 50 to 100 types of particles exist inside the atom. But out of these all, the very important and fundamental particles are these three, which are constituting an atom mainly, are these three. They are electron, proton, and neutron. Okay, that's about subatomic particles. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates on recorded videos.